Okay, I want to show you guys a couple of cool uses for sine. Let's do these two questions. Can you find the length of the longest side of the following triangle? Well, the longest side looks like it's right here. Now, I have an angle and I have a side. I want to use trig. The problem is I can't use trig. Anybody know why? Here's the answer. It's not a right triangle. Can't use trig unless you have a right triangle. That stinks. Can I find the area of this triangle here? What's the area of any triangle? 1/2 base times height. Well, looks like the base is 8, and looks like the height, I'd have to measure it from the top here, down here, to make a right triangle. Can't even bother. Don't have the height. No height. Can't do it. All right, we're going to relate sine to area, all right? And I'm going to show you what I'm going to end up doing. Now, this is called an oblique triangle. All an oblique triangle is, it's a non-right triangle. And you're allowed to use sine and cosine when you have non-right triangles. But there's certain things you got to do with it. Okay, watch. I'm going to take this big triangle here, triangle ABC, and I'm going to actually find an area formula for it. Watch what's going to happen. Okay, I just want you to notice something about this diagram. They use capital letters for the angles, angle A, angle B, angle C, and then they use lowercase letters, right, for the sides. And if you notice, across from angle A, all the way across from it on the other side is lowercase a. Across from B is lowercase b, across from C is lowercase c. When you're using these special sine and cosine formulas, that's what they're going to do. They're going to label the triangle in some specific way, and they're always going to write whatever letter, they're going to write it in a lowercase opposite it, okay? All right, area is 1/2 base times height. The base is down here. We'll call that lowercase b for right now. The height, I had to actually draw it into this triangle. You guys have seen this before. I drew it in and I made a right triangle. Now, watch what I'm going to do for sine. I'm actually going to do the sine of this angle over here, which is A. What does that represent? Well, sine is the opposite, which would be H, over the hypotenuse. Well, the hypotenuse looks like it's C. Do you guys realize that I actually used the height here in my sine ratio? The opposite of A was H, so I actually used it to set up a ratio. Watch what I'm going to do here. I'm going to cross multiply this guy. H times 1 is H, sine A times C, and I'm going to write it like this. C times the sine of A. And I don't know if you noticed, but I actually can use sine of A times C, right? Which is the hypotenuse to A. If I multiply those together, if I do the sine of A times C, it should tell me what the height is. That'll work on any oblique triangle. And all I'm going to do is I'm going to take whatever I figure out for H, and I'm going to plug it into the formula there. So I can actually use sine to actually make a formula, a new formula, called 1/2 b, right? And I'm going to do C times the sine of A. And if you notice, if I use sine of A, it uses the entire base here, and it uses this side over here, which is C. And basically, I just actually I derived a new area formula using the likes of sine. Now, not to be confusing, but people will say, well, I don't want to use angle A. I want to use angle C. No problem. Watch what happens. Let's do the sine of C. What's the sine of C? It would be H over A. Just did the sine of C in this little right triangle over here, because you know what? You draw the height in here, you get right angles, right? That's H over A. What if I cross multiply that? The height would equal A times the sine of C. Interesting. What if I take what I get for the height and I plug it in? What do I end up with? You get another formula, and it looks like this. 1/2 the base times, now look, I'm going to do side A times the sine of C. All right? And this is another formula, right, that I can use to find the area. It just depends on what side are you going to use on the triangle. Are you going to do the sine of A or are you going to do the sine of C? If you do, just look. Little c represents the left side of the triangle, the big one, and little a represents the right side of the big triangle. And so it depends on what angles you're going to use. You'll use, right, the opposite sides to it. Interesting, huh? Now, if any of you guys are thinking, you're going to go, well, what about angle B? All right, well, the base is there, right? Watch what ends up happening, okay? Watch. If, right, and I should do it over here, and I would have to draw the diagram differently, but here, let's come over here. If I wanted to do the sine of B, right, okay, I would actually have to draw maybe it over here, right? You know, I would have to actually make a right triangle, which is going to be kind of hard. I would need a different diagram for it, okay? But what's going to end up happening is if you're going to do the sine of B, and I should make that capital B, right, okay? What's going to end up happening is, and I don't have a nice diagram for it, right, okay? So I can't draw it on here, but this is what's going to end up happening, okay? Instead of using B as the base, I might have to use either A or C as the base. Instead of using B as the base, maybe A or C would be the base. So basically, this is just going to end up being, right, I'm going to have to use sides A and C, and I'm going to have to do sine of B. And I can't really use this diagram to draw it in there because it doesn't work. But if I wanted to do the sine of B, I would still need the sides of little a and little c, the lowercase letters. And this would be a third formula I would end up using. And I just want to point something out here. If you do the sine of A, notice you're using the sides that are next to A. This is kind of like a side angle side situation, right? If you're going to use angle A, it's in between the two sides you're going to use C and B, right? C, sine of A, got B and C over here, you got to multiply. If I use the sine of C, what two sides are next to C? A and B. See how that's A and B over here? Now, if I redraw the diagram and I want to use angle B, right, okay, then I got to use angle B is in between which two sides, A and C? So basically, that's how the formula works. So on any oblique triangle, there are 3 formulas you can use to find the area, and it all depends on what sine you're going to use. Are you going to do the sine of one angle, okay? You're going to do sine of another angle? Or are you going to do sine of maybe the third angle? And I have no idea what angle you're going to use. But just remember, this angle is in between the two sides. And if you know that, this is really, really easy. Rewind the video if you need help. I'm going to do a couple problems right now, and this is on your homework, and there's no IXL for these, right? Okay? All right. Determine the area of the following triangles. Guys, I want to use one of these formulas, right? And so watch what I'm going to end up doing. I don't have the height in here. You could try to draw it in, but you don't need it. We're going to use the sine of angle A, which is 72 degrees, right? Okay? The area formula says you got to do 1/2, right? You're going to do the sine of 72, that's angle A, and it's in between which two sides, 10 and 7, right? You could call this B, and we could call this C, right? Lowercase b is across from angle B, lowercase c. All right, we could do 7 times 10, right? And guys, I'm going to be completely honest. All you have to do is throw that into your calculator. Throw it into your calculator and you're done. That's it. So, again, for some of you guys, I'm going to check to make sure the mode's on degree. It's there. I'm basically going to type in, right? Okay. Now, I like to do parentheses when I do a half. Let's get rid of this. I'm going to do parentheses 1/2, right? Okay. We're going to do 17 times 10, and then I'm going to put parentheses sine of 72 degrees, right? Okay. And you know what? I'm actually going to try. Let's just try to do times the sine of 72 because you'll end up with too many parentheses in there. Well, there you go. 1/2 times 17 times 10 times the sine of 72. It gives me this. The area is 80.2 Does it tell me how to round? No. All right, let's do to the nearest hundredth, right? Okay. And we'll do centimeters squared. That's what the area is. That's it. Easy. Let's do the next one. Area equals. I want to do the sine of C, right? So I want to do the sine of 23 degrees, okay? Look, you got 6 and 12, right? Okay, 1/2, let's do 12 times 6. You know what? You could put you put these in parentheses. It doesn't matter. It's just multiplied times itself. So all you guys got to do is this, right? Okay, how about this? Instead of doing a fraction, we'll do 0.5 times, what was it? Times 12 times 6 and times the sine of 23. That might be the easiest way to do it in calculator because the sign forces you to do parentheses. So if you just do that, you type it in. The area to this triangle is it's 14.07 centimeters squared. That's it. Done. Easy. Let's do one more. Let's do this one. So remember, I'm going to use B, right? So that's the sine of 36, right? And if you care, this is little a and this is little c. We just got to multiply them together. And it doesn't matter what order you do them in. But here, we'll do times. Let's do times. We'll do times 11 times 15 times that. And you guys need your calculator, right? I mean, I can't do any of this in my head. I'll do 0.5 to be easy. Times 11 times 15 times the sine of 36, right? And the area to this is 48.49, and this one's centimeters squared. So there's my area for that one. There's my area for this one. And there's my area for that one. And I use sine on a non-right triangle, which is pretty cool. All right, I'm gonna draw a diagram ABC. We're gonna calculate the area for this one. And it's really, really easy. Doesn't matter how you draw your triangle. A, B, C. Doesn't matter how you draw it, right? It says angle A is 110 degrees. That's great. Now it says B. Remember, across from angle B is little b. So we're going to make that 5 centimeters. And across from C is little c. That's going to be 2 centimeters. And again, if you were listening to me, this is an angle-side angle. This is a side-angle-side relationship. This angle that we're going to do sines is in between the two sides, which we're going to multiply. Just remember the area formula. It's 1/2 times base and height. Okay, we'll do it as times 5 times 2, and we'll do times the sine of 110. All right, and just get your calculator out. All right, we'll do 0.5 so we don't get confused. All right, times 5 times 2 times the sine of 110 degrees, right? And the area for this is 4 point, right? All right, we're gonna have to round this to 70 if I do 2 decimal places, but it doesn't tell me, so it doesn't matter, all right? And